Next, chapter 7, triangles, introduction it is. So in this section what we are learning is congruence, which you have already learned in 7th standard. So what do you mean by congruence of two figures? Congruence of two figures means that figures with the same shape and size. Two figures are said to be congruent if they have same shape and size. Same shape and size. So two figures are said to be congruent if they have same size and shape. Example, circle of same radius. Circle of radius, two circles of radius 2 centimeter. They are congruent because they are of same shape and size. Then what we are going to learn is congruent triangles. Two triangles are congruent if they are of same size. That is correct. But for doing the problems, what we are learning here is two triangles are congruent if their corresponding sides are equal and corresponding angles are equal. Corresponding sides are equal and corresponding angles are equal. Two triangles are said to be congruent if their corresponding sides are equal and corresponding angles are equal. So for that, if you are getting two triangles in hand, how can you check whether they are of same size and shape? How can you check whether they are congruent? Actually what we are using here is keeping one over the other. See, I am keeping one over the other. If it is completely covers, we can say both these are congruent. The same way you can keep one over the other, one triangle over the other. If it completely covers, then what we can say, both the triangles are congruent. So what I said is corresponding sides and corresponding angles. I want to explain that. Listen, this is a triangle in which triangle ABC and triangle PQR, in which AB is equal to PQ, BC is equal to QR, AC is equal to PR, and angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. AB is equal to PQ, BC is equal to QR, AC is equal to PR, and angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. This means that corresponding and sides are equal. So what this means is AB and PQ are corresponding sides. So when we keep triangle PQR over this triangle ABC, these two vertices will coincide and B and Q come together, then C and R come together. So when you keep one over the other, A and P coincides, B and Q coincides, C and R coincides. These are A and P are known as corresponding vertices or corresponding angles. Angle B and angle Q are known as corresponding angles. Angle C and angle R corresponding angles, which you have already learned in 7th standard. We are using this symbol. Angle A corresponds to angle P. Angle B corresponds to angle Q. Angle C corresponds to angle R. In the same way, AB corresponds to PQ. If you start with AB, you should start with P itself. And AC and P are the corresponding sides. BC and QR are the corresponding sides. So when you name the side or vertices, you have to take the corresponding side or corresponding vertex itself. So if you start with B, you have to start with Q, BC and QR. If you start with the CB, we are saying it as CB, you have to write it as RQ. So, what is given is AB is equal to PQ, BC is equal to QR, AC is equal to PR. So, what we can say is triangle ABC is congruent to triangle PQR. This is the condition. Corresponding sides should be equal and corresponding angles should be equal. Two triangles are said to be congruent if their corresponding sides are equal and corresponding angles are equal. So, if AB is equal to PQ, BC is equal to QR and AC is equal to PR, and angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, we can say triangle ABC is congruent to triangle PQR. Triangle ABC is congruent to triangle PQR. We can write this as triangle ABC. The congruent symbol is this, congruent to triangle PQR. This is the symbol which we are using to represent congruence. So, if we write A here, you should start P here. Then we have written B, then it should be Q. Then C, then R. What I said is, you have to start, when you name it, you have to start with the corresponding vertices itself. So, this is the symbol which we are using to represent congruence. Then, instead of proving all these, we have some congruence rule which you have already learned in 7th standard. The first one is SAS congruence rule. SAS congruence rule means if two triangles are congruent, if two sides on included angle of one triangle are equal to two sides on included angle of the other triangle. It should be corresponding sides. Consider triangle ABC and triangle PQR. What it says is, two triangles are congruent if two sides on included angle AB is equal to PQ and AC is equal to PR, and the included angle is this, angle A and angle P. Included angle of these two sides is angle A. Included angle of these two sides is angle P. So, if AB is equal to PQ, AC is equal to PR and angle A is equal to angle P, then we can say triangle ABC is congruent to triangle PQR using SAS criterion. Two sides, so SS, in between angles, so SAS. If two sides on included angle of one triangle are equal to the corresponding two sides on included angle of another triangle, then both the triangles are congruent using SAS criterion. So, we are going to do example 1. Example 1, in figure, OA is equal to OB and OD is equal to OC. Show that triangle AOD is congruent to triangle BOC and AD is parallel to BC. For this kind of problem, what you have to write first is, what are the given things which you have to write. So, given things you have to write first. So, given, that's the first one. What is given? OA is equal to OB, OD is equal to OC. Then, next one what you have to write is, what to prove. To prove, first one, triangle AOD is congruent to triangle BOC, and second one, AD parallel to BC. Triangle AOD congruent to triangle BOC, and second one, AD parallel to BC. So, when you get a question like this, if the question from any of the geometry section, you have to write the given things first, then what to prove, then proof. So, here we are going to prove triangle AOD is congruent to BOC. For that, Next is proof. So what is given? OA is equal to OB, OD is equal to OC is given. So two sides are given. OA is equal to OB, OC is equal to OD, or OD is equal to OC. Two sides are given. So we have to check whether the included angles are equal. Is it equal? What about these two angles? These two angles are vertically opposite angles. But when you name it, it should be using the corresponding parts. So first I am writing angle AOD. Angle AOD. So we have started from here. This is the end point of this side. This with which one has one? Which has one line. So OA is the side which has one line. So I have to start with the one line itself and other vertices. So B angle BOC. You have to write vertically opposite angles. This is how the corresponding parts. We have started from AOD. So corresponding part of A is B because this is the side which shows one line. So when you mark like this, it is easy for you. So AOD is equal to angle BOC, vertically opposite angles. So triangle AOD is congruent to AOD is congruent to BOC using SAS criterion. When you use any of the criterions, you have to mention the name there. So triangle AOD is congruent to triangle BOC using SAS criterion. Then what is the next one which we have to prove? We have to prove that AD parallel to BC. AD parallel to BC. How can you prove? Parallel. To prove two lines are parallel, what are the different conditions you have learned? So when two lines are parallel, or if a line intersect two parallel lines, then their corresponding angles are equal. Alternate interior angles are equal. Interior angles on the same side of the transversal are supplementary. If any one of this condition is satisfied, we can say both the lines are parallel. If two lines are parallel and if a transversal passes through this, we can say first one is parallel lines are given. If two parallel lines are given, corresponding sides are equal, alternate interior angles are equal, and interior angles on the same side of the transversal supplementary. The converse is also true. That means if any one of this condition is satisfied, that means if corresponding angles are equal, we can say both the lines are parallel. If alternate interior angles are equal, we can say both the lines are parallel. If interior angles on the same side of the transversal are supplementary, we can say both the lines are parallel. So any one of this we have to use because we have to prove that these two lines are parallel. We want to prove AD is parallel to BC. So can you prove using any one of this? We can. See, these two angles are equal. Why? These two angles are equal because both the triangles are congruent. So if triangles are congruent means all the corresponding sides are equal and all the corresponding angles are equal. So angle A is equal to angle B. Why? Because these two triangles are congruent. If these two triangles are congruent, all the corresponding angles are equal and all the corresponding sides are equal. And what is the reason for this, which you have already learned in 7th standard? Corresponding parts of congruent triangles, which you can name as CPCT. Angle A is equal to angle B because using CPCT, and angle A and angle B are equal means the alternate interior angles are equal. Why? Here AB is the transversal. Here AB acts as a transversal for AD and BC. So we can say angle A is equal to angle B using CPCT. This implies that AD parallel to BC using alternate interior angles are equal. Alternate interior angles are equal. So we proved, hence the proof. Next question, example 2. AB is a line segment. AB is a line segment and L is its perpendicular bisector. If a point P lies on L, show that P is equidistant from A and B. So what is given? L is the perpendicular bisector. What to prove? What do you have to prove? P is equidistant from A and B. That means to prove P is equidistant from A and B means AP is equal to BP. To prove AP is equal to BP. What is given? Given thing is L is the perpendicular bisector. What do you mean by perpendicular bisector? Perpendicular means it makes 90 degree. Bisector means divides the line into two equal parts. So L is a line which makes 90 degree here and which divides this line AB into two equal parts. That is what meant by perpendicular bisector. So we can write the proof. What is the proof? First one is this: angle ACP is equal to angle BCP is equal to 90 degree is given, because it is given that L is the perpendicular bisector and AC is equal to BC is that is also given. Why I have written as AC is equal to BC? Because what I said is we can, for checking the congruence, we can keep one over the other. For identifying the corresponding parts also, we can keep one over the other. So if you want to keep this triangle over the other, just fold it. Am I right? Just fold it. When you fold, here P and P will coincide, A and B will coincide, and C and C will coincide. Clear? That is how we are identifying the corresponding parts, by keeping one over the other. So for keeping one over the other, you can just fold it. So P and P, A and B, C and C. So A and B are the corresponding parts for both the triangles C and C, and last one is P and P itself. So that is why I have written this as AC is equal to BC. So we got one angle and one side, which is the other angle which we can take. PC. PC is equal to PC common. PC is equal to PC common. So what we can say? Triangle ACP. ACP is congruent to triangle BCP using SAS criterion. Two sides are included angle. So if these two triangles are congruent, we can say AP is equal to BP using CPCT. This implies that AP is equal to CP using CPCT. This is the proof which we need.